give you a step-by-step instruction on what we here at UCC do to measure the density of some of the compounds we make for the wire and cable industry. Normally they refer to the parameter we're going to measure as density or a certain weight per unit volume, but in the rubber and plastic industry they've come up with a dimensionless quantity representative of the parameter of density, which they refer to as a specific gravity, which is defined, I believe, as 1 cubic centimeter of water, distilled water at sea level, I believe at room temperature. And they define that as a specific gravity of 1. And what we will do is compare the ratio of our plastics or rubber to a gravity of 1. So the first step will be to take a sample approximately at between 1 and 2 grams, and we will get a weight out to 4 decimal places. So that's the first step. So for this compound here, dry, the sample weighs 1.4233 grams. Then the next step we're going to want to do is to get a residual weight after we immerse this specimen in distilled water. In order for us to do that, we attach this little wire which helps us suspend this to get a weight, or again, how much does this specimen lose weight once it's immersed in distilled water. So the first step is to weigh the specimen without the wire. Then for the final calculation we'll weigh the specimen again with the wire. And again, our scale is out to 4 decimal places, and it is enclosed in a wind-resistant chamber. So now with the wire we're getting a weight of 1.4675 grams. So now we will introduce to this our little saddle pan, if you will, which we suspend above the weigh platform, and then what do we have here? 250 milliliter beaker full of distilled water. And then we will immerse this specimen in here and get a weight reading. To see how much residual weight we have after. I'm going to raise this up a little bit because the beaker's down a little bit too low. Because the important part of this test is to make sure that the specimen is completely immersed in the distilled water and not touching any of the sides of the beaker. So I'll get a top view to be sure it's not touching any of the sides, and then like this here to be sure that we're getting, and then we'll get a residual. So in fact what we're doing is we already know that most of our compounds that we make have a gravity greater than 1, or in other words heavier than 1. So in a sense we're getting a reading of how much heavier than water that this specimen is right now. I'm getting a reading of 0.2749. And after we get, that's as far as what's required as far as scale, use of the scale to get the weight and the weight loss. And then what we will then do is to subtract, which is the weight of the specimen and the little wire. And from that we will subtract the weight that we just determined. And we will get 1.1962, and then we will divide that ratio from the original weight of the specimen divided by the weight loss after immersion in water. And we get, as the specific gravity, 1.193, which for our purposes, the resolution is good enough to 2 decimal places. So our gravity would be 1.19. And for this particular compound, our spec limit is 1.21 plus or minus 0.02. So by this mere method, this specimen needs to require, which again states that the operators down in the plant weighed up all of the raw ingredients in the proper proportions when we mix the compound. That's about it for specific gravity.